So welcome to National 4, National 5 Chemistry. We're looking at Unit 1, Formulae and Calculations, and today's lesson is going to be looking at balancing chemical equations. So the aim is to learn how to balance chemical equations, and in terms of success criteria, we want you to be able to balance the chemical equation if you're given the chemical formula, and be able to identify reactants and products in a chemical equation. So, chemical equations. Chemical equations are an easy way of describing a chemical reaction. These equations are said to be balanced when there is the same number of each type of atom on both sides of the equation. So we're going to look and talk through an example. So what happens when calcium burns? Now, when any element burns, that means it reacts with oxygen. So the word equation for this reaction would be calcium plus oxygen goes to calcium oxide. So specifically, we have a plus sign between chemicals on the same side of an arrow, and we have an arrow showing that the things on the left-hand side are turning into the things on the right-hand side, and that this chemical reaction only goes one direction. The reactants, calcium and oxygen, are written on the left side of the arrow. So anything written on the left-hand side of the arrow in a chemical equation are called reactants. Calcium oxide is the product and it's written on the right-hand side. There can be more than one product. If you have more than one reactant or more than one product, use a plus sign to show that they are formed together or that they are reacting together. Now, a chemical equation is simply written by replacing the words with your chemical symbols and chemical formula. So in this case, calcium, we use the symbol for the metal calcium, Ca. Oxygen, we put in O2 because remember oxygen is one of the diatomic elements, so it is O2. And if you worked out the chemical formula for calcium oxide, you'd find that it is CaO. Now, unfortunately, this equation is not balanced. By balanced, we mean having the exact same number of each type of atom, each type of element, on either side of the equation. So if you look at this equation, if you look on the left-hand side, there are 2 oxygen atoms and 1 calcium atom. But on the right-hand side, we have 1 calcium atom, that's good, that's balanced, but we only have 1 oxygen atom. So the oxygen is not balanced. Well, what do we do to make sure that it's balanced? To balance it, you need to adjust the number of formula units of some of the substances until you get equal numbers of each type. And by adjust the number of formula units, what we mean is multiply the chemical formula. So put a number in front of the chemical formula to say that, oh, well, we're making 2 of those or 3 of those instead. So here goes. If we put a 2 in front of calcium oxide, we're saying that, okay, in this experiment, we are making 2 equivalents or 2 units of calcium oxide in this reaction. Now, what the number 2 does is it multiplies everything after it. So that means that the calcium is being multiplied by 2 and the oxygen is being multiplied by 2 on the right-hand side. So we have 2 oxygen atoms on the right-hand side and we have 2 oxygen atoms on the left-hand side. But there are now 2 calcium atoms on the right-hand side and only 1 on the left-hand side. So it's not balanced and we need to do something to balance it. And what we do is we put a 2 in front of the calcium. So that 2 multiplies the calcium, but then once we get to the plus sign, that 2 is no longer multiplying anything. This is a balanced chemical equation. We have 2 calcium on the left-hand side, 2 oxygen on the left-hand side, and we have got 2 calcium and 2 oxygen on the right-hand side as well. So we'll just go through a slightly different way of explaining that, which leads up to the same sort of procedure. But a balanced equation is one where there are the same number of atoms of each element on either side of the arrow. So a good starting point is to look at an equation that's already balanced. So this one is magnesium reacting with chlorine. Mg plus Cl2 goes to MgCl2. If we look at the magnesium, we've got 1 magnesium on the left-hand side, 1 magnesium on the right-hand side. We have got 2 chlorines on the left-hand side, 2 chlorines on the right-hand side, which meant that that was balanced. Now, not every equation starts out being balanced. So what I've got on this slide, we've got 3 elements, magnesium, hydrogen, and sodium, each reacting with chlorine. And what I'd like you to do is just take a little bit of time to see how many, if any, of these equations are balanced and which ones are not balanced. Remember, balanced means having the same number of each type of atom on the left-hand side of the arrow and the right-hand side of the arrow. So hopefully you've had a good time to look at those, and you should have identified that the top one, the magnesium one, is balanced, but the other 2 are not balanced. And what we'll look through is what we can do to make sure that those ones become balanced. Now, our rules for balancing equations is, firstly, we never change the chemical formula. We instead put a big, large number in front of a chemical formula and it multiplies the whole thing. Each chemical can have a different number, and you can keep multiplying until the chemical equation is balanced. So if we look at this example, hydrogen plus chlorine going to hydrogen chloride. Well, if we count the atoms, we have 2 hydrogen on the left-hand side, 2 chlorine on the left-hand side, and on the right-hand side, we have 1 hydrogen and 1 chlorine. In order to balance this equation, we need 2 hydrogen and 2 chlorine on the right-hand side. So a way to do this is we put a big number 2 in front of hydrogen and chlorine. That number 2 in front of a chemical multiplies everything by that number. So now we have 2 hydrogen, 2 chlorine on the left-hand side, and 2 hydrogen and 2 chlorine on the right-hand side. So that equation is now balanced. So we only needed to multiply 1 chemical to balance that equation. So now we've got the example of sodium reacting with chlorine. So what we do is we start and we count how many of each type of atom there are on either side of the arrow. So on the left-hand side, we've got 1 sodium atom and we've got 2 chlorine atoms. On the right-hand side, we've got 1 sodium atom and 1 chlorine atom. Our sodiums are balanced, but our chlorines are not balanced. So what we do, our first step is to try and get our chlorine atoms balanced. So if we've got 2 on the left-hand side, that means we need 2 on the right-hand side. We cannot change the chemical formula. All we can do is add a big number in front of it, which multiplies everything. And so in order to get 2 chlorines, we would put a big number 2 in front of sodium chloride. Now if we count our atoms up again, we've got 1 sodium and 2 chlorine on the left-hand side, and on the right-hand side, well, now we've got 2 sodium and 2 chlorine. And this means that, well, our sodiums are not balanced, but our chlorines are balanced. Now what we do this time is we take a step to try and balance the sodium atoms. Well, we've got 2 on the right-hand side, we need 2 on the left-hand side. So if we put a big number 2 in front of the sodium to multiply just it by 2, hopefully that will get us to a balanced situation. So if we look, we've now got 2 sodium and 2 chlorine on the left-hand side, and we've got 2 sodium and 2 chlorine on the right-hand side. Our sodium are balanced and our chlorine is balanced, and so we have our desired balanced equation. So again, just going over the steps. Step 1 is make sure all the chemical formula are correct. You'll often be given the chemical formula. The second thing is make sure whenever you're balancing an equation that you only try and balance one element at a time. If you try and balance the whole thing at once, it becomes very confusing. So always write out the elements and then deal with one that's not balanced, try and get it balanced, then re-look at the equation and try and balance something else. We balance by writing numbers in front of chemical formula. You cannot change any of the numbers within a formula. And step 4 is to check each element again and repeat the balancing if needed. So now what we've got are some examples for you to try. I suggest that you pause the video. There's going to be 2 slides. So pause the video, we'll look at these answers, then I'll show you the answers, then we'll show you some new questions. So hopefully you've paused the video and had time to look at the answers. But for the first one, we just need to add a 2 in front of bromine. For the second one, we needed to add a 2 in front of the sodium oxide, but then we also needed to add a 4 in front of the sodium. For the third one, we needed to add a 2 in front of magnesium and a 2 in front of magnesium oxide. For the fourth one, we need to add numbers in front of every chemical. So a 2 in front of aluminium, a 3 in front of chlorine, and a 2 in front of aluminium chloride. Now I've got another set of examples here. Again, pause the video and have a go at these. If you've just unpaused the video, we're about to go through the answers to these questions. So for the first one, we needed to add a 2 in front of sulfur dioxide and a 2 in front of sulfur trioxide to balance that equation. For number 6, all we needed was a 2 in front of hydrogen iodide. For question 7, we needed to put a number in front of every chemical, 2 in front of phosphorus, 3 in front of chlorine, and 2 in front of phosphorus chloride. And for our final question there, what we needed was 6 oxygen on the left-hand side, producing 4 carbon dioxide and 4 water molecules. So that was us looking at balancing chemical equations, a really important skill that you will get tested on and is important if you take chemistry further. Hopefully you are able to balance a chemical equation from the chemical formula and you're able to identify reactants and products in a chemical equation. Our next lesson will be on using gram formula mass to be able to work out how much of a chemical you will need in a chemical reaction.